Hi, this is a 3D modeling and then a rendering demonstration using AutoCAD initially and then moving on to 3D Studio Max. It's a pretty basic setup. We've just got a building sitting on a plot on a sloping site, and I'll show you how I kind of work with generate my own kind of landscape using a kind of limited amount of information, and then take that through to 3D Studio. So I'm just going to shade this just so you can see what the kind of the end result in AutoCAD anyway. Okay, so it's a fairly simple arrangement: road, pavements, flat actual site for the building, but we've got sloping land around the building, and also a fence going around that with posts spaced out evenly. So there's quite a lot of components in this, and I hope you find it useful. So we'll be starting with a 2D material over here, and I'm just going to strip it back a wee bit. I'm just going to get rid of the kind of finished articles here, and we've got some contours here that I'm going to generate as well. So these are going to be in a slightly different position. Okay, I'll take away this. So this is the kind of start off situation. Put it back to 2D wireframe. Okay, so everything here is flat 2D information. Okay, I'm just going to make sure that we've got things flat on the ground, because we've got the Z coordinates of these lines are all 0. Everything's 0. Now we're going to kind of bring everything up to the levels that we've got to work with. So this is the kind of the only information we've got. I've got two spot heights on the road, 3.25 meters and a 5.75 meters. So that's my kind of starting point. And usually roads are generally kind of fairly even in this direction. They don't tend to kind of go up and down too much. So we'll say that the gradient between these two spot heights is constant. Okay, so what I'm going to do is draw a 3D polyline that starts at a certain height. Okay, so let's see what layers I've got to work with here. So I'll use this 2D levels layer. Okay, and I want a 3D poly. Okay, it could be a normal line, doesn't have to be a polyline, to be honest. The start point of the line is going to be the X and the Y coordinate of this cross, but it'll ask me then for the height that I want to use. So use a filter for this. So you type in .xy, and then it says .xy of where. Okay, it's going to be the intersection or the midpoint here, and then it says I now need the Z information. Okay, so the height there is 3250. Okay, so you can see where the line is starting. It's 3.25 meters above the plan position, and we're going to .xy of this position, but to a height of 5750. Enter to finish. Okay, so you see how that is fed in. We've got a line going from those points, and if you had more spot heights to work with, you could continue those further on. Okay, now what I want to do is kind of judge where the contours would be in relation to this. Okay, so let's say we need a contour at every kind of meter interval, or every half meter interval. So how many half meter positions are we going to have between here? Okay, so it's 5.75 minus 3.25, so that's 2.5 meters. Okay, so if we say every 250 mil, so if we have 10 gaps here, we should be able to count where the contours should occur. So if I divide that line by 10, okay, so that's 3.25, 3.5, 3.75, 4, take away these ones. That's 4, 4.25, 4.5, 4.75, 5, 5.25, 5.5, etc. So you get the idea? You can kind of work out roughly where the contours should occur. Okay, it'd be good if I could extend this line, so I'm going to do that. I'm just going to draw a line across each end, and then we can extend the 3D polyline across to that. Same at this end. Okay. So then we can judge where the 3 meter contour should be. So it'll be about this, the distance that we've got here. So let's work that out. If I draw a 2D polyline from midpoint to node, that's the distance away that this contour would be. So what I'm doing here is called interpolation. So if I move this point, move this line, okay, the next node point, the next contour should be at this point here. Okay, and that's a wee bit tricky to establish. What we need to do is kind of trim the line. So if I just draw a line and then trim it off, that's where my 3 meter contour should be. So I'll go from a node point there to the end point. And I can extend that again if I want to. Okay, you see how that's kind of done? Using the distance on the line. I could use that line again actually. Let's just copy it. Let's just move it across to the other end, because the distance will be the same. Okay, and a line to use to trim with. Trim it off. Okay, so that will be the 6 meter contour there. So let's copy this node to the end point and then extend it again. Okay, so I'm not going to work with every half meter contour here. It'll take a bit too long to work out the landscape, so I'll just go with the meter one. So that's 3 meters, that's 3.5, we'll get rid of that. That's 4 meters, 4.5, we'll dispose of that. 5 meters, 5.5, I'm not using that, and then we've got 6 meters out here. Okay, so that should help us draw the contours. And so we've got some points in space to help us generate our own contours. Okay, and I'm going to use my contour layer, 2D contours. Okay, I can go to the plan now. Okay, and I'll start at the node point. So I'm going to add that to my object snaps, using it quite a lot here. Okay, so these want to be polylines because we want to keep them the same height. Okay, so I'm going to start with a straight section just to make it a bit easier to draw. Okay, and then we'll say that the ground is curving away, that kind of affair. Draw another polyline from this contour. Okay, I'll turn my snaps off temporarily. Let's come to here. Okay, I'll space them out a bit if I want to. Pull snaps back on. Polyline. Pull snaps off just temporarily. Final one. Let's get the contour up here. Maybe the line's going a bit evenly in this direction. Okay, so if I identify these points, I should have a Z height of 3 meters, 5 meters at this one, 6 meters here. All looks to be behaving correctly. And spin it over, we've got the slope of the land. Okay, this is just interpolated from 2 spot heights on the road. Okay, we're not going to be doing any modelling on this side of the road, So the contours, it's okay if just the contours are going in that direction. Okay, and the purpose of this is so that we can establish the boundary of the site and find out the height of the land at the boundaries, so that we can model the edge of the site properly. Okay, so we've got the blue line is effectively the boundary line on this side of the road, so that's an even slope. So we can use the line itself to help us set up this. So this is what we'll say is that this will be the edge of the site, okay, and then the roadway will be slightly lower than that to give it a bit of form. Okay, so what I'm going to do is move this line, okay, because the midpoint here should be at the same distance. Let's just check. Delta x 0. Oh, we've got a slight difference in position there. So what I'm going to do is just trim that off and use the line to move it to the pavement. Okay, and then I'm going to copy that line using the edges of the pavement. So we've got some kind of 2D setting out here. Okay, so that's the edge of the site on that side. Okay, what we need to find out is the position where the site crosses this line, the corner positions, okay, and where it crosses the edge of the site at this point. So kind of need to look down on this now. So use the plan command to give yourself a top-down view. Okay, and I'm just going to use the 2D boundaries to trim the 3D line. Okay, so that should give us where the boundary crosses the site. So let's put a little circle on these just to differentiate. So I'm just going to use a little circle here. Okay, I could extend that again if I wanted to. Let's bring it back to its original length. We should be hitting that. We should be hitting this. Plan again. Okay, these ones are a bit trickier. Okay, how do we establish where this point is? Now what I do here is draw a normal line from contour to contour that passes through this point. Okay, so we need to start off with a polyline initially. So we need to be able to get to this point. Okay, so I'll go from this point because that's at 0. I want to go I want to go to touch the contour at any point. So just the nearest will do. Okay, but bear in mind that's a flat line. Okay, and if we extend that to the far away contour, that's the direction of the line that we need to go in. Okay, so go back to the plan. So we're trying to find where this point will be in 3D. Okay, so we need a point on the actual contour. So I'm just going to draw another line on top of the contour, something that I can trim and work with. So if I trim, okay, this is a bit tricky, but that's where the trimmings have ended up. Okay, so if I draw a 3D line now from here to here, it's in the same plan position as this, but this one's sloping by ½ meter. So they're both on top of each other. If I turn this over, you can see that happen. Okay, get rid of this one because it's misleading. Get rid of these two. Okay, and then we can use the boundary here to trim this line, and it should give us the point where the corner of the site, well, the 3D height position at the corner of the site. trim this line, and we've got our position there. Okay, let's do that again for this corner of the site. Okay, so we go back to the plan. Okay, we draw a polyline from this corner, and I want to just go to the nearest point. So I'm roughly perpendicular. It's kind of, you've got to kind of do this by eye. So it's roughly perpendicular there to a kind of the middle of each contour. Extend this over to the other contour. Okay, we need a sacrificial line. Okay, now we can trim using this line, and it gives us the points on the contours. Okay, so I tip it over. Okay, so we're going from the end of this line to the end of this line. Okay, so this is very accurate. It's a very accurate way of doing things. Get rid of the 2D line, then trim the 3D line with the 2D line, and it gives us our point in space that we can then connect to. Our boundary passes over the contour here. Okay, so if we, I don't know if this is trimmable. Yeah, that's going to trim there. So we've got a third point here that we're passing through. So our boundary goes from circle to circle to circle. So it gives us a much more accurate 3D setup. Okay, so we're going from circle to circle, circle to circle to circle, and then back along to this circle. So that's the 3D site boundary. I'm not sure if I've got a layer for that. Don't think I do in particular. Not a 3D site. I'll use 3D site ground. Let's use that one. Okay. So you can use polylines, or you could use normal lines here. So going from center to center, 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 center. Okay, and then I'll take it back down to here. So that's our 3D site boundary. So we'll start kind of turning off some of this 2D stuff now. So we can get rid of that one. We're more than likely, well, we haven't finished with the contours just yet. We'll use those when we triangulate the ground. Okay, we need to know where the driveway hits the pavement. So this should be just trimmable. Okay, we use the circles again just because they're easy to see. So that's where the driveway hits the ground. And for this site, we're saying that it's a flat site. So we'd basically kind of be choosing a level ourselves. You know, we don't want to cut too much material out. We don't want to add too much material. So, you know, a height in between these two contours is most likely to be the sensible choice. So if we said that the site itself was at a height of 3.5 meters, that should work pretty okay. So what I'm going to do is draw a polyline around the site. I'm going to go perpendicular to here. Okay, and then we'll change that to an elevation of 3.5 meters. Okay, and you may not have seen this being done before. We'll use the change command, but use -CH. Enter. Pick the line. Enter. We want to change a property. We can change the elevation of the line. And we want to choose a height of 3.5 meters. So, well, actually, be 4.5 meters, wasn't it? 4500. 2 enters at the end there, brings it up to the required level. Okay, and then we've got a sloping driveway, so it goes from end here to centre and end here to centre. So that driveway's got some twist on it. You can see that when I twist it, when I turn it around. Okay, it's just the nature of it. If we're level, if we're at a constant level here, and this is sloping, then this portion has to twist. Okay, so that's our setting out in 3D. I'll just switch off the roads now. These two lines aren't needed anymore, and we're ready to go to the next portion, which is surfacing these various items. So I'm going to stop this video just now so we move on to the next portion.